Hello and welcome. In this video, we're going to talk about angles formed by transversals. Our goals in this lesson are that we can define, identify, and apply the definitions of different types of angle pairs around a transversal, and that we can use parallel lines cut by transversals to prove various relationships between those angle pairs and define their angle measures. Let's go ahead and jump in. All right, let's go ahead and start with our vocabulary. A transversal, which is the big word in this lesson, a transversal is a line that cuts through another line at different points. So in each of these pictures below, line T is representing the transversal. Two angles are corresponding angles. So the transversal is going to cut through and form a variety of different angles. Two angles are called corresponding angles if they are in the same position but beside a different line. So it's sort of like they have the same seat, but they're a row back. Two angles are alternate interior angles when they're both on the inside, but they're on either side. They're alternating across the transversal, or they are on opposite sides of the transversal. Two angles are alternate exterior angles. So here we're seeing that word exterior instead of the word interior, alternate exterior angles, when they lie outside the two lines and on opposite sides of the transversal. So they're my corners, my edges. These two angles would also be alternating exterior. And then lastly, two angles are consecutive interior angles. These are also called same side interior angles. If they are on the same side of the transversal, they're beside each other. So let's go ahead and actually add or underline same side, consecutive interior angles. So now that we've talked about these various vocabulary words, these different types of angles formed by a transversal, let's go ahead and look at an example where we are identifying them given a transversal and some lines. Okay, so here we have a line cut by a transversal. Right here is our transversal. This line is cutting through the other two lines and forming all of these angles from 1 to 8. So this line here is our transversal. Our corresponding angles are the angles that are in the same position, but they're on different lines. So one example is 1 and 5, but also 2 and 6. So which angle is corresponding to angle 3? That's right, that would be angle 7. And which is corresponding to angle 4? That would be angle 8. So they're in the same position, but beside a different line that's cut by the transversal. So let's go ahead and list those angles out. Angle 1 goes with angle 5, 2 and 6, 3 and 7, 4 and 8. Next, let's look at alternate interior angles. So if I'm looking at these two lines, everything in here would be interior. So I'm looking for angles that are on opposite sides of the transversal that are inside. So here, that would be 2 and 7, and it would also be 4 and 5. Next, let's talk about alternate exterior angles. So I'm still looking at the same two lines that are being cut by this transversal, but now the exterior are all the angles that are on the outside, not inside those two lines. And alternating, meaning they're on opposite sides. So angle 1, who's on the opposite side, and on the exterior, that would be angle 8. And angle 3 would go with angle 6. And lastly, consecutive interior. So again, interior means we're looking in here. And consecutive means they're on the same side. So in this case, 2 and 5, and 4 and 7. So hopefully these vocabulary words are really starting to click because we're now going to get some theorems that give us information about them. Okay, each of these 4 theorems are associated with two lines that are parallel. This is indicating that they're parallel, and they're being cut by a transversal. So you'll notice that each of these theorems starts with the expression or the hypothesis if two parallel lines are cut by a transversal. So I want you to know that The examples that we just did, we didn't have any information about the lines being parallel. And in order for this to be true, the lines have to be parallel. If the lines aren't parallel, we don't know anything about these angle relationships other than the vocabulary that we have discussed. So if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So each corresponding angle actually has the same measure. So if angle 1 was 115 degrees, then angle 5 is 115 degrees. But also 3 and 7 would have the same measure. 2 and 6 would have the same measure. 4 and 8. So all of those angles that are corresponding would have the same angle measure because they are congruent. Only if these two lines are parallel. Now, similarly, if we talk about the alternate interior angle theorem, if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So, for example, angle 3 and angle 6, also 4 and 5, would have the same measure if the two lines are parallel and they're being cut by the transversal. Next, the alternate exterior angles are also congruent. So like I'm saying, pretty powerful ability if two lines are parallel and cut by a transversal. So in this case, 2 and 7 would be the same, and 1 and 8 would have the same measure. Those angles are congruent. And then lastly, the consecutive interior angles are, and this is the one that's actually a little bit different, they are supplementary. They add to be 180 degrees, which we could prove, we aren't going to, but we could prove using the linear pair postulate. These two angles have to add to be 180. These two angles have to add to be 180 because they're linear pairs. Since 1 and 5 are the same, that means that 5 and 3 must also be supplementary. That's the supplementary angle theorem. That would be sort of like the transitive property there. But big idea with all of these theorems, corresponding alternate interior and alternate exterior angles are all congruent if we have a set of parallel lines cut by a transversal. Consecutive interior angles are supplementary. So now that we know these properties, let's go ahead and apply them in some examples. All right, in this example, we have a line, a transversal, that is cutting through two parallel lines, and we are given that this angle is 120 degrees. And we're being asked to find the other angles and to explain how we know or why we know that angle is the amount that it is. So let's first start with corresponding angles. We know that angle 5 is in the spot that corresponds to the 120 degree angle. So that means that angle 5 must also be 120 degrees. Since these lines are parallel, this is true by the corresponding angles theorem. I'm going to draw a symbol for angles and abbreviate theorem. Now, I also know, and there's a lot of different ways to go about this, but I also know that angle 4 is going to be 120 degrees because these two angles are vertical angles. So angle 4 is 120 degrees because of the vertical angles theorem, which we learned in a different section. Or I could say that angle 4 must be 120 degrees because it's an alternate interior angle to angle 5. So there's a variety of different reasons we can draw the conclusions that we are drawing. Angle 8 is an alternate exterior angle to the 120 degree angle. So 120 degrees because of the alternate exterior angles theorem. And now there's a variety of ways that we can go. I have a whole bunch of linear pairs. So for example, I know that angle 3 and angle 2, which are vertical to each other, but they're also forming a linear pair with the 120 degree angle, which means 180, which is how much it is to be a linear pair, minus 120 is going to give me 60 degrees. So angles 2 and 3 are both 60 degrees, and we can either say that's because of the linear pair postulate, or I could say the linear pair postulate for angle 2 and then vertical angles for angle 3. But I'm just going to write the linear pair postulate twice because that is actually how I was thinking about it. What do we have left? 6 and 7. Well, if we look at angle 3, which we just found to be 60, angle 6 is the alternate exterior angle to that. So angle 6 must also be 60 degrees. Alternate exterior angles theorem. And then lastly, number 7 is vertical to number 6, or number 7 is a linear pair to 5 and 8. Either way, the measure of angle 7 is going to be 60 degrees, and I'm going to say because of the vertical angles theorem. So there's a lot of different ways to go about doing this, but it's really important that you understand that relationship that's occurring between the angles formed by the parallel lines and the transversal. All right, let's look at some more examples. All right, I'm going to encourage you to pause the video and see if you can find the value of x in each of these problems on your own. And we are actually stopping at find the value of x. It doesn't say to find a specific angle. But while you're doing it, I want you to think through and identify what allows you to make the statements that you're making. Then unpause the video and see how you did. All right, hopefully you had time to work through this on your own. What I know to be true is that the measure of angle 4 on problem number 3 must be 115 degrees because these two angles are vertical angles, so the vertical angles theorem. Then I know that these two angles are on the same side. They are consecutive interior angles, consecutive interior, which the theorem for consecutive interior angles says that those two angles are supplementary. So 115 plus x plus 5 must equal 180. If I add 115 and 5, I get 120, and if I subtract that on both sides, I'm going to get 60 degrees. And I can check to make sure that makes sense. If I plug 60 in for x, I would get 65. 65 and 115 is 180. So that does make sense. So x is going to equal 60. For problem number 4, I can determine that the measure of angle 1 is going to be 44 degrees because these two angles form a linear pair, and that linear pair must add to be 180. So 180 minus 136 is 44 degrees. Once I have done that, and again, there are different routes to go about. Once I have done that, I now have alternate exterior angles, and they are equal according to the alternate exterior angle theorem. So I can say that 44 is equal to 7x plus 9. If I subtract 9 on both sides, I'm going to get that 7x is equal to 35, which means that x is equal to 5. And I could double check that this works. 35 plus 9 is 44, and that is what it was supposed to be equal to. So now that we've worked with these angle relationships, let's go ahead and look at a proof and then wrap up this section. Okay, we've been doing proofs for a couple chapters now. We had a couple full sections of proofs, so I'm going to encourage you to pause this video and see if you can fill anything in on this table, see if you can work through it all the way, and then unpause the video and see how you did. Okay, I'm going to try to think out loud here. The first thing that I want to look at is my roadmap. So we are given that these two lines are parallel, which also we can see that this is a transversal cutting through it. Our goal is to prove that angle 1 and angle 2 are congruent. So we're proving the alternate interior angles theorem using something else. So if I'm looking at my proof, my first thought is I know that P being parallel to Q was given, and I know that my roadmap is telling me that I'm trying to prove that angle 1 and angle 2 are congruent. So I'm working through the rest of this. So anytime I'm looking at a proof that's partially filled out, when I get to a new piece, I ask myself 2 questions. First question, does this look like a variation of the statement before? No. Which means second question, where am I getting this from the picture? So if it isn't just a slight change to the statement before, I'm looking at the picture. So how do I know that angles 1 and 3 are congruent? Well, those are corresponding angles. So I could say that I know this to be true because of the corresponding angles theorem. Corresponding angles theorem. And then it says that we're going to use the vertical angles theorem. Well, the vertical angles theorem tells me that all angles that are vertical are congruent. So that must be a way that I'm associating angle 2 and 3. So I can say angle 2 is congruent to angle 3. And then my goal is to go from 2 and 3 to 1 and 2. So what I see is angle 1 is congruent to angle 3, and angle 2 is congruent to angle 3, which means by the transitive property, or even by substitution, if I substitute angle 1 in for angle 3, either way, by the transitive property or substitution, angles 1 and 2 must be equal. So the transitive property of congruence. And that was our last example in this section. 4.4, we did it. 4.4 was all about angles formed by transversals. We defined those different types of angles. We called them by their name. And then we learned a bunch of theorems that associated congruence and supplementary angles with the different types of angles, as long as the lines are parallel. That's a really important detail. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.